Hey guys, this is Ron. So in this video we'll talk about EIGRP and default routes. So sometimes in your network you'll have a router that interfaces with your internet service provider. In our case here, that's router 1. So router 1 is our exit node for our network. Well, router 1 should push out some type of default route to router 2 and router 3. And this is because obviously we're not going to have routes to every network on the internet, right? So router 2 and router 3 should have entries for the local network, and then they should have a single default route for everything else. And that default route should say, hey, go to R1 to get out of the network. In EIGRP, there's two main methods for building those default routes. You can use the IP default network statement, or you can build some type of static route and redistribute it. Now the first method, as you'll see, is a little awkward to get up and running, but it's really not that difficult. I personally don't tend to use it much. I tend to redistribute some type of static route. However, there are cases when you have multiple static routes on a router, and so redistributing every one of those static routes may cause other issues in your network, and so you can't necessarily get away with just a redistribute static, and that's where the IP default network statement might come in handy. So let's go ahead and set it up and get this configured. So in the network in front of you, everything is IP'd. EIGRP is up and running between router 1, router 2, and router 3. The ISP has a single interface 10.0.0.1, and it shares that network with router 1. So router 1 also has NAT configured to allow for these quad 1, quad 2, and quad 3 networks to be translated into the 10.0.0.0 network before leaving R1. And this is because the ISP doesn't necessarily know about every route within our network, right? But we want to be able to interact with the ISP. So again, those things are already configured, and what we'll work on in this lab is building a default route to push from R1 down to R2 and R3. So on R1, let's go ahead and start with the IP default network method. So it is a little odd. The default network statement only works with a classful IP. And so you may or may not have a classful IP to use on your router. So a lot of the routers that I work with, everything is subnetted, everything is kind of customized, you know, to reduce the size of networks, so I'm not wasting IP addresses. And so I may or may not have a classful IP to choose from. In that case, what I'm going to do is I'm going to build a loopback address, and I'm going to give that loopback address a classful IP. And so you'll want to make sure that whatever IP you give it obviously doesn't conflict with anything in your network. So interface L1, I'll give it IP address 192.168. We'll go with 1.1, and we'll give it a classful subnet mask for the 192.168. So we have a class C network here using 192.168.1.1. We'll want to go ahead and advertise that into EIGRP so the rest of the network knows how to get to this address. Alright, so now that network is in EIGRP. And we'll compare our tables here. So I have 192.168.1.0 network, right? Go ahead and copy that. I have no gateway of last resort, and I have no candidate default, right? So none of these routes are marked with an asterisk. If I go to router 2, I have the same thing. no candidate defaults, none of these are marked with an asterisk, and I have no gateway of last resort. But I'm aware now of the 192.168.1.0 network. So if I go back to router 1, IP default network, and I'll put that address in. So the 192.168.1.0. Alright. So now if I do show IP route, something has changed here. I now have an asterisk. Okay, so this 192.168.1.0 network has been marked as the candidate default. And if I look on R2 now, a couple things have changed here as well. So this route is in fact marked as the candidate default, and I now have a gateway of last resort. All right? So the gateway of last resort is headed for network 192.168.1.0, which is the candidate default down here. And to get there, I'm going to send it to 192.168.12.1. 12.1 is the network shared between router 1 and router 2. If I look on R3, I also have a candidate default now, and I have a gateway of last resort, which is the 1.0 network, and to get there I'm going to 13.1, which is the network shared between router 1 and router 3. Okay, so I now have candidate defaults in my network. However, when I look on R1, R1 marks this as a candidate default, but it has no gateway, right? So it pushes out the candidate default to everyone else, but it doesn't set its own gateway. So we have to do that manually. And so we'll do this with a basic static route. So IP route, so quad zeros, and this is my ISP router's IP. So if I do a show IP route now, I have a static route. That static route is also a candidate default, and it marks this as my gateway of last resort. So 10.0.0.1 is my ISP. If I look on R2, nothing has changed on R2. I still have the original candidate default network, and I'm going to send it to router 1. So if I do a ping, so I've set up quad 8 on my ISP router. So if I ping that and source it from L0, because I have to come from an interface that I have programmed in NAT on router 1, I can hit it, right? So quad 8 is not currently in my network table or in my routing table. However, because I have this gateway of last resort now, it sends it to 12.1. It's received by R1. It looks in its table. It doesn't have quad 8s there. So it looks to its gateway of last resort and sends it out to ISP1. And so ISP1 has that interface and it replies to quad 8. Okay, so that's how to set up and push out a default route using the IP default network statement. Now again, there was quite a few little things that we had to jump through to get that working. We had to have a classful interface. We had to make sure that that interface was in EIGRP, and then we set it as the default network state. Or the default network for the router, right? And then lastly, we created our own static route so that router 1 would actually have a gateway. Now router 1 might not have to do that if maybe one of its interfaces got its IP address via DHCP. So maybe the ISP assigns my router an IP, and so by doing that, oftentimes router 1 will automatically make the ISP router its default gateway. And so in that case, I wouldn't have to build a static route. But I manually assigned my IPs here, and so I had to actually add that static route. So let's try it via redistribute static. So I'm going to take away some of the configuration changes I made here. So no interface L1, no IP default network 192.168.1.0, router EIGRP 1, no network 192.168.1.0. So if I look on R2, I cannot ping quad 8s anymore. If I do a show IP route on R3, I no longer have a candidate default network, and I no longer have a gateway of last resort. But I do still have my static route. So if I do a do show IP route, I still have my gateway of last resort because I still have my static route that I built pointing everything to 10.0.0.1. Now to push that out to my other routers, all I have to do is router EIGRP1 redistribute static. Okay, so now I take this static route and I push it into EIGRP. And so what I end up with on my other routers is they now have a gateway of last resort, which again is to my 12.1 interface, because this is the interface between router 1 and router 2. And they have an entry now for quad 0, learned via EIGRP. It is a candidate default because of the asterisk. And the EX indicates that this is an EIGRP external route. And that's because the static route existed external from EIGRP, and I redistributed into EIGRP. Okay? So they now have a route that acts as their gateway. And so now I can ping quad 8s again. So a little easier to get up and running. I don't have to add a classful network. I don't have to add another network under EIGRP. You know, there's different things that I no longer have to do. I simply do redistribute static and I'm good to go. Now again, this may not fit your bill if you have multiple static routes on your router and you don't want to redistribute every one of those. Okay, so you may have to go in and do some extra configuration, maybe do some filtering, and it gets to be a pain, and so maybe you'll look at the IP default network statement. Now stay tuned. We'll talk about default routes again when we do OSPF, and I actually prefer the OSPF method, but we'll take a look at it here in a bit. I hope you found this helpful. Again, I tend to redistribute static, but it's up to you and your network. Thanks for watching. Bye.